Hello, good morning. So in the today's class we are starting new units, that is the unit third of our syllabus, paper second, that is unit third, and this unit name is the elasticity. So elasticity, as we know already in the 12th science, elasticity, there is a simple concept, elasticity. So first of all we have to know the basic definitions of this elasticity. So for that we are taking basic definitions. So first is the rigid body means what? So rigid body, as we know already, rigid body. So this rigid body means rigid body. Firstly, what is the rigid body? There are some basic definitions we have to recall from the 12th science. Rigid body. So rigid body means a body is said to be rigid if the force applied to it produces no change or negligible change in its size and shape, but no actual body is a rigid one. So all bodies, whether the solids or fluid, undergoes the change in shape and size, or both, depending on their nature. So when the external forces are applied to them, so that's why there is no any rigid body, but we can say only a rigid body which has the change, only negligible change when we apply a force. Okay, so the second one is the elastic body. Elastic body. So if a body regain completely its original size and shape on the removal of the deforming forces. So what is the deforming forces? So when we apply external forces, the change in the shape or size of the body, so this external force is known as the deformation, deforming force. This force is called the deforming force, and the body which has a change by applying force is called the deformation. Means change in the body of the when we apply a force is called the deformations, and the force which we use to change the shape and size of the body is called the deforming forces. So what is the elastic body? The body which can regain its original size and shape after the removal of deforming forces, it is said to be perfectly elastic body, and this property of change in the original size and shape of the body is called the elasticity. That is the first concept, elasticity. Elasticity means the body which regain its original size and shape after the removal of deforming forces is called elastic body, and property is called the elasticity. So the examples of this elasticity are the, for example, rubber. First example is the examples are rubber. First example is the rubber. Second example is the metals. The next examples are the quartz. So these are the examples of elastic body. So then next definition is the plastic body and plasticity. So this is exactly opposite to the elastic body. The body which cannot regain its original size and shape after the removal of deforming forces is called the plastic body, and the property is called the plasticity. So the examples of this plastic body is the, for example, clay, putty, example is the plasticine, thick mud, and plasticine. So these are the examples of plastic body. Exactly opposite we have to write here only cannot. Okay. The body which cannot regain its original size and shape after the removal of deforming forces is called the plastic body, and the property is called the plasticity. For examples, clay, putty, thick mud, plasticity. So these are the basic definitions of rigid body, plastic body, elastic body. So the next one is the perfectly elastic body. Perfectly elastic. No actual body is perfectly elastic or perfectly plastic. It is a behavior lies between these two limits, that was plasticity or elasticity. This is the only behavior, not body exactly. So if a body regain its original shape and size completely and instantaneously upon the removal of deforming forces, then it is called the perfectly elastic. Third is the perfectly elastic. The body which regain its original size and shape, its original size and shape completely and instantaneously after the removal of upon the removal of deforming forces, that body is called then it is said to be perfectly elastic. Then it is said to be perfectly elastic body. Perfectly elastic body. Okay. So these are the definitions which we have to study before the topic start. So then next one is the isotropic body. Isotropic body, these are the other type of body, isotropic body. So it is the material which is the body. If the material of which body is composed has same physical properties in every direction. Once again, if the material of which the body is composed has same physical properties in all directions, the body is said to be isotropic body. So we have to neglect this definition, but we have to understand what is the means. We have to recall this isotropic body. So if the material of which the body is composed has the same physical properties in any direction, the body is said to be isotropic. So then next one is the stress. So we already know the stress and strain in the 12th science, but we have to recall this in your topic. So what is meant by stress? Stress. So when the external force acting on the body produce some deformation of the body, so internal restoring forces between the two adjacent molecules on either side of the section through the body is set up in it this. So this force tends to restore the original size and shape of the body. When every portion of the body is in equilibrium, the internal restoring force per unit area is called the stress. That is, in equilibrium condition, the magnitude of the stress is equal and opposite to the magnitude of the applied force per unit area. So this simply stress is nothing but so the definition of stress is the magnitude of applied force divided by area on which he acts. Area on which it acts. So the magnitude of this applied force, the magnitude of this stress is equal and opposite. So the stress is equal in magnitude of the stress is equal to the magnitude of applied forces. So this is the definition of stress. So suppose F is the force acting over a small area A of the body at any angle to its surface, then the stress is equal to, which can be write as the stress is equals to component of force normal to area divided by area. So this is another definition of stress. So simply we can write this: internal restoring force divided by area. Simply stress is equals to force per unit area. That is internal restoring force, it is called the F divided by area A. Therefore stress is equals to force per unit area. This is the definition of stress, and the unit of this stress is the Newton per meter square in SI unit, and dyne per centimeter square, this is in the CGS unit. And the dimension of this stress, dimension is equals to dimension of force divided by dimension of area. So as we already know, the dimension of force is the m1 L1 T minus 2. That is m1 L1 T minus 2. And the dimension of area means length square, that is the L2. So after counting this, we get m1 1 minus 2, that is minus 1, and T minus 2. So this is the dimension of m1 L minus 1 T minus 2. This is the dimension of stress. Okay. Unit, SI unit is the Newton per meter square, and CGS unit is the dyne per centimeter square, and this is the dimension. So stress is not a vector quantity because no specific directions can be assigned to it. It is also not a square quantity. That is this is not the vector and scalar. This is the simple stress because this force has no direction. So that's why this is simple internal restoring force divided by area. We have taken here magnitude of applied force. So that's why no directions, though no quantity, that is vector, no vector and no scalar quantity is the stress. So there are three types of stress. First one is the longitudinal stress, second is the volume stress, and third is the shearing stress, as we already know. So these three types of stress we are seeing in the next class. Thank you.